Hi guys, so today we're going to go over just a brief tutorial on how to sketch a polygraph. So there are steps to this. The first step is to test the symmetry of the polygraph. So I did do a separate video on testing the symmetry, but there is also a symmetry test for polygraphs reference sheet as well posted here. So I'm just going to show you quickly on how to test the symmetry of the polygraph and why it's significant when we're graphing. So starting off, I'm going to replace r and theta with r and negative theta. So given this example, I'm going to change 3 plus 2 cosine of theta into 3 plus 2 times cosine of negative theta. And if you go back to module 5, under even and odd identities, you'll note that cosine of negative theta equals to cosine of theta because it's an even function. Remember in module 1, if you replace x with negative x, it comes out the same as it's an even function. So same deal here. It's under the even function for your trig identities in module 5. Cosine and its reciprocal secant are the only even functions within those trig identities if it helps simplify things. So I'm going to bring this down. Knowing that cosine of theta equals cosine of theta. So everything is the same. If it ends up the same as what it began with, um, after you do whatever it says to do in the polar graph symmetry test, then that's what it's symmetric to. Because it came out the same, this is symmetric to the x-axis. So there is a reason why we want to know that. Just think of the x-axis, which they'll also refer to as the polar axis in a polar graph. The x-axis is the polar axis. That means that one side of the x-axis will look just like the other side of the x-axis. That means everything in quadrant 1 and 2 will look just like everything in quadrant 3 and 4. So this is going to be your mirror right here. From there, we'll identify the shape of the polar graph. So I want you to keep in mind, this is 3 plus 2 cosine theta. I'm going to switch the page real quick. And if you look here, A and B are just numbers. It's not going to be a circle because it doesn't match A sine theta, A cosine theta. Remember, we have 3 plus 2 cosine of theta. That's what our equation is. If you look under limacons, it does match that. So A plus or minus B sine theta or A plus or minus B cosine theta. So what we have here is A plus B cosine theta. Just like in module 2 with quadratics, A, B, and C are just numbers. So it matches this. Now we compare, what kind of graph are we expecting to see? Well, is A greater than or is A less than B? 3 is A and B is 2. So that is not the case. This is not going to have an inner loop. A does not equal to B. But in this case, A is greater than B. So this is the shape we can expect. The symmetry with the referred diagram is symmetric to the y-axis, but it could be symmetric to the x-axis as well. It's just like when you draw a parabola, it could face upwards, it could face downwards, but this is just a kind of an example of what to expect. So this is the diagram we should expect to sketch. And then the last thing is that we're just going to make a theta r table, just like an xy table, but you're dealing with a polar graph. And just like an xy is the graph for when you graph a line, a parabola, you should have circles drawn in for your polar graph. There is a reason for that. So we're going to make a theta r table to begin with. So starting off, I just want you to remember that this is symmetric with respect to the x-axis. For that reason, I'm only going to pick angles from quadrant 1 and 2. Why? Because since it's symmetric, whatever quadrant 1 and 2 look like, I know quadrant 3 and 4 will look the exact same way. So that's taking away half your work here. Some angles I'll pick out from the unit circle. And again, it's just like when you choose x, y, or x values for your table. There's no right or wrong. You're just picking some values. So I'm just picking values from quadrants 1 and 2. I think I'll use pi over 2 as well. 2 pi over 3, and let's go with pi. So just like the x and y table, you're going to replace the theta with the value and go from there. So 3 plus 2 cosine of 0. Unit circle time. Cosine of 0 is 1. And then don't forget PEMDAS. multiply. 2 times 1 is 2, and then 3 plus 2 is 5. That means at the angle 0, I'm going to make a point on the fifth circle. 1, 2, 3, 4, 5. And then pi over 3. So r equals 3 plus 2 times cosine of pi over 3. The cosine of pi over 3 is 1/2. Bringing everything else down, multiply first. 2 times a half is 1, and 1 plus 3 is 4. That means at pi over 3, which is about 60 degrees here, I'm going to make a point on the fourth circle. And remember that one side of the x-axis looks like the other side of the x-axis, so I'm going to make a point here as well. And then pi over 2. So I'm running out of room here, so I'm just going to make this here. 3 plus 2 times cosine of pi over 2. The cosine of pi over 2 is 0. 0 times anything is 0. And then 3 plus 0 would give me 3. So at pi over 2, I'm going to make a point on the third circle. Again, it's symmetric with respect to the x-axis. So one side of the x-axis looks like the other side. So I'll make a point on this third circle as well. And then 2 pi over 3. So r equals 2 times 2 plus, sorry, messing up the equation. R equals 3 plus 2 times cosine of 2 pi over 3. The cosine of 2 pi over 3 is negative 1/2. Bringing everything else down, 2 times negative 1/2 is negative 1. And negative 1 plus 3 gives me 2. So at 2 pi over 3, which is right here, 120 degrees, I'm going to make a point on the second circle. One side of the x-axis looks like the other side of the x-axis. So I'll also make a point on the second circle here. And last, since I'm out of room, I'm just going to chalk this one out. Cosine of pi. Well, cosine of pi is a negative 1, and negative 1 times 2 is negative 2. 3 plus negative 2 gives me 1. So when theta is pi, which is at this angle, I make a point on the first circle. And if you connect the dots, you already have the shape that we saw on the reference sheet. Now, mind you, I cannot draw, so I'm trying here. But this is your Limacon. All right, guys, hope this helps.